Good evening once again. I'm going to solve the question from thermodynamics lesson. So this is a JE question. Let us solve the first question. 2 mole of an ideal gas is expanded isothermally and reversibly from 1 liter to 10 liter at 300 Kelvin. The enthalpy change in kilojoule per mole, kilojoule for the process is. So they are asking delta H. The first question, they are asking the delta H. This is actually the first question. Delta H will be what? Okay. You can think like that. Actually, delta H has the formula, right? Delta H is equal to, according to chemistry thermodynamics, delta H will be equal to, that is delta E will be equal to delta H plus W, right? This is actually a chemistry thermodynamics relationship. So delta H is equal to minus W. In the NCERT, they have clearly mentioned the first law, delta E is equal to delta H plus P delta V, that is delta H plus W. W will be, that is W is minus nRT for a reversible process. nRT 2.303 log V2 by V1. This is the actual formula for isothermal reversible expansion work done. So when you are substituting that you can get the delta H positive value. But actually here, look at this. This is an ideal gas. So be clear on that point. Ideal gas. For an ideal gas, delta E, actually for isothermal process, delta E will be always 0. So that's why we are getting delta H is equal to minus W in isothermal process. But in the case of ideal gas, look at this, ideal gas will not react with each other, right? So ideal gas, whatever may be, whether you are taking 1 mole or that is, there will not be any interaction, there will not be any intermolecular attraction. So it cannot form any combination. So we could not get the change in the number of moles of an ideal gas. So delta n will be always 0. Delta n is 0 means, so we are having another one formula for calculating delta H. Delta H is equal to delta E plus delta n G R T. There will not be any intermolecular force of attraction when the ideal gas undergoing isothermal expansion. So intermolecular force of attraction is not there, means there will not be any change in the number of moles of gas. So delta Ng will be 0. For isothermal process, delta E is always 0. So delta H is equal to 0. That is the answer for the first question. But you may get confused by giving the answers. In some websites, they have given the answer like this. W is equal to, that is, they have applied the number of moles to and R value in 8.3 and 300 Kelvin and 2.303 log 10 by 1. Like that, they have applied and they have got the answer 11.4 kilojoule. But that is wrong, because this is an ideal gas. For ideal gas, always delta H is 0 for isothermal expansion. So the answer is 0 kilojoule for the first question. And the second question, let us solve the second question. First question we have finished, and I am going to solve the second question. Please look at this once more. Delta H will be 0 as well as delta E will be 0, because this is an ideal gas and isothermal process. And then the second question, the enthalpy of vaporization of a liquid is 30 kilojoule per mole. So 1 mole of liquid will be in equilibrium on the vaporization process, right? When it will be in equilibrium, in the case of vaporization, liquid will be converted into gas at the boiling point. At the boiling temperature, liquid and gas will be in equilibrium. So what will happen actually for equilibrium process, we know about that. That is delta G is equal to delta H minus T. Delta is the original formula. And delta G will be 0 for that case, and delta H is equal to delta H is equal to delta H minus T delta S. It will be delta H will be equal to T delta S. So they are asking the boiling temperature. So at the boiling point, the process will be in equilibrium. That is, liquid to gas process will be in equilibrium. So delta H divided by delta S. So T is equal to delta H divided by delta S. So what they are asking, the temperature only they are asking. Delta H will be 30 kilojoule. So I'm going to convert that into joules because enthalpy, entropy is in the joule unit. That's why I have converted like that. So 30 divided by 75. Let us calculate from the calculator, but actually please don't use the calculator. I'm using the calculator now because I should not take your time, right? That's why. But please don't use the calculator. So it will be 0.4 into 10 to the power 3 approximate. Actually, it is 400 Kelvin. So T is equal to 400 Kelvin. Let us see whether our answer is right. Yes, our answer is right. 400 Kelvin is right there. So please look at this. And one more point. At that boiling temperature, liquid will be in equilibrium with the gas. That is why we have taken delta G as 0. If it is not in a reversible process, then we should not apply that thing, right? Thank you.